Hello there, how is it going? Welcome to the video series on interrogating data with Python Pandas. So let's first understand what is Pandas. Pandas is an open source BSD licensed library. It provides high performance, easy to use data structures and data analysis tools for interrogating data using Python programming language. The best thing about Pandas is that there are only two data structures and the name of these data structures are DataFrame and series, popularly known as Pandas DataFrame and Pandas series. There are various reasons for which you might use Pandas, but one of the most obvious reason is interrogating data. When you have large set of data, you want to extract some valuable information, and for that reason you might want to use Pandas. So let's start our journey with Python Pandas. Now there are two data structures, data frame and series. In this particular video we will concentrate on Pandas data frame first. Now before I go ahead and explain you Pandas data frame, here is a note. Most of the time if you go ahead and look into online tutorials, or for that matter even the official documentation, they start explaining Pandas series first before data frame. But based on my own experience, I am convinced that we should learn and explore Pandas data frame first, because learning series will be a super easy job once we understand Pandas data frame. That's the reason I am starting with Pandas data frame, and by the end of this particular video you will understand why. Okay, so let's start our journey with Pandas data frame. Now let's answer a very obvious question first. What is a data frame? The technical answer is data frame is a 2D labeled data structure with columns of potentially different type. The simple answer is Pandas data frame is just like an Excel sheet. Yes, you heard it correct. Pandas data frame is just like an Excel sheet, as you can see in your screen right now. Just like in an Excel sheet, we can store 2D data as being depicted in this particular picture right now. Here the heading is name, age and designation, and I have 7 records of different people who have different name, age and may or may not be same designation. A Pandas data frame is nothing but a programmatic representation of Excel-like data in memory. Now I hope I was able to explain you in a very clear terms what is meant by Pandas data frame, and I hope and believe that you will not forget it now. Let's go ahead and ask one more obvious question. Why do we need it? We already have Excel sheet, we can process data in Excel sheet, right? Wrong. Pandas data frame not only allows large amount of data to be stored in memory, but also provide various functionalities to analyze, change and extract the valuable information using Python programming language. And believe me, these functionalities are extremely valuable and the API list is huge. We will go through each one of them in upcoming videos. So once we extract the valuable information, these information can be used for various purposes, including but not limited to machine learning and data analytics. So let's go ahead and get some hands-on with Pandas data frame. Okay. Now, Pandas provide various APIs to read the data from various locations. It can read the data from files including CSV files as well as from databases like MySQL databases. However, we can also create Pandas data frame from Python data structures like dictionary and list. Now we have just seen an Excel data. For this data, let's create a dictionary using name, age and designation as key and their values as list, and then we can create our own data frame using the dictionary. So as a prerequisite, we will import Numpy as NP and Pandas as PD. We will be using Numpy down the line in this particular video. I'm just importing it at one place. So I'm importing these two and I am creating my dictionary on the data which was displayed in the Excel sheet. So this is my dictionary. Now to get a data frame from a dictionary, we will use this API called DataFrame, pandas.dataframe, and we can just pass our dictionary in it. And I did that, and here is how my data frame looks like. Isn't it look very similar to the Excel sheet? Now you might be seeing one difference, that age comes first, designation comes next and name comes last. However, if you go back to my dict, we will see that name is first, age is second, designation is last. So this has nothing to do with the data frame. Pandas data frame doesn't rearrange the columns. It's because of my dictionary. Dictionaries are kind of hash and it doesn't preserve the order. So in here you can see that age, designation and name is the sequence of column stored in this particular dictionary. Now one important thing, in this particular dictionary I didn't provided a row index number, but you can see that the row index number is generated automatically by Pandas data frame. That's the beauty of Pandas data frame. It automatically generates row index number as well as columns if you don't provide one. We will see that in few minutes. Now in here Pandas data frame has automatically generated the row index number, but if we don't want Pandas data frame to generate it, we can provide our own row index number. We can do this by passing a parameter called index in the data frame function, and in the index I can provide a list which can be used as a row index number. So if I go ahead and do that, you can see that 10, 20, 30, 40 till 70 is my new row index number. As of now I have provided just the integers, but it is not limited to integers. We can also provide strings as part of index, as I am doing it over here. So if I pass string as an index, you can see that strings are now the row index, like first, second, third, fourth, fifth, sixth and seventh. Now you remember that I have imported Numpy along with Pandas in the beginning. Why? Because Pandas and Numpy goes hand in hand. There are various places where we can use the Numpy array. For example, index can very well be a Numpy array. So I have created a Numpy array using numpy.arrange function. So I want to generate a number between 0 to 35 with a difference of 5. And once I generated this number, I am passing this number as an index. So if I do that, my data frame will look like this. Now you can see that my index are 0, 5, 10, 15 till 30. One thing you have to be careful about whenever you are passing the index, the number of elements should match number of rows in the data frame, otherwise it will throw you an error. Now once my data frame is created, it's possible for me to add a new column to the existing data frame. In fact, it's very simple as creating a variable. The way to do it is that I can create a new column by calling data frame square brackets, writing the name of new column and passing the list. And if I do that, my data frame will look like this. You can see that new column is being added in my data frame. Again, you have to be careful about number of elements in the new column. It has to match the existing number of elements in the data frame, otherwise it will throw you an error. As we have generated the index from Numpy array, we can also generate a column from Numpy array. So here is how I can use a Numpy array to generate a column. So what I am doing over here is that I am calling a numpy.ones function, which will give me 7 elements, which will be having the value as 1. And I am creating the column name as new space second column. Remember, new space, mind it, space second column, and putting it to nparr. So when I just go ahead and print my data frame, this is how my data frame looks like. You can see that new second column is also added as part of my data frame. As you can guess that I am passing numpy arrays as my column. And if you are aware of numpy arrays, you know that elements of a numpy array will always be of same type. So same is true for columns. Each column of a pandas data frame is of same type. So unlike Python list and just like Numpy, a column of data frame will always be of same type. So if you want to know what is the type of a column, there are two ways of doing it. First is like I am calling the data frame and I am passing the column name and I am using dot operator to say d type. So now you can see that it's showing me data type as int64. I can even use dot notation like df.age.dtype. It will give me same output, but this is preferred. I'll tell you why. Let's check the type of name. So if I just go ahead and print it, it will give me data type of object. And let me check that data type of new column. It will print me data type as int64. Now I said that this approach is preferred because if we have a column name which is having a space in between, and if you want to access the d type, there is no way for the Python interpreter to know what I want. it will say df.new. There is nothing known as df.new. After a space, it looks like some different command altogether. To handle this kind of scenarios, we can use this subscript .dtype and we will get the data type. In here I am getting data type as float. Okay. Now if you are tired looking into individual column data type, you can check the data type of each column by calling dtype on data frame. Now you can see that the data type for all the columns is represented over here. Now once we store data into a data frame, the next logical step is to extract the data from the data frame. In this case, I have just put 7 records, but most often than not, Pandas data frame will contain hundreds if not thousands and thousands of rows at any point of time. To selectively extract the row, we can use head and tail function, which by default gives first or last 5 rows if no input is provided. So let's see how it works. If I say df.head, it gives me top 5 values. If I say df.tail, it gives me bottom 5 values. If I say df.head by passing a number 2, it gives me top 2 values. But if I say df.head passing a number 7, it gives me top 7 values, and it can actually extend the by default 5 because I have provided explicitly a number called 7. Same thing for tail, it will give me bottom 7 records. This is the way we can get top and bottom records from a data frame. This is generally useful to get an idea of what kind of records that are there and what are the data types. Now, once you have a data frame, before doing any processing on that data frame, you want to know the index as well as columns. To get an index, you can call df.index, and to get the column you can call df.columns. I am also providing index shape and column shape just to let you know that they are actually returned as a Numpy arrays. Okay, so now you can get a feeling of deep bonding between Pandas data frame and Numpy arrays. Now interrogation of data is not complete unless and until we manage to fetch some selective data. So I'll be creating a totally separate video on various functionalities of fetching selective data. But in this particular case, let's take a couple of examples. So let's talk about unique function. Unique function helps us to extract unique elements from a column. For example, in designation, we know that there are multiple people might be having same designations. So what are the unique designations? I get the unique designation as a Numpy array, which is VP, CEO, CFO and MD. There are mathematical functions like mean to get the mean of a column. For example, 30.14 is the mean age of all the records. Now we know that Pandas data frame automatically generate a row index number for us. But what if we don't want that? Look, if you are having thousands and thousands of records, it is taking memory. You don't want Pandas data frame to generate one additional column for you because it will be taking a lot of memory. And it might also be the case that you already have a row index number in your data. In that case, what will you do? You can assign one of the column as row index number. In that case, by default generated row index number will vanish from the data frame. Let's go back and see our original data frame first. So this was our original data frame with auto generated row index number. Now what I will do is that I'll set the index as name column. In this case, name column will become row index number and age and designation will be column. I can even do the same to age. In here you can see that age becomes the row index number and other columns becomes the column of the data frame. We can even set multiple columns as row index number as in here. I am setting name and age as row index number and designation as the column. So all this permutation and combination you can do. Now while loading large amount of data, sometimes you might experience that loading all the data takes a lot of time and you know that all the data is not valuable. For example, there might be 20-25 columns and you might be interested in only 5 or 6 columns. So you want to load only those. What you can do is that you can selectively load columns in data frame by specifying the column name. In this particular case, I am specifying the column name by passing a parameter called columns and passing the list in it containing the column names. So in this particular case, my data frame will load only name and age. For some reason, if you have already loaded all the columns and if you want to delete some of them, you can actually delete rows and column from the data frame very easily. Let's go back and create our original data frame. This was our original data frame. Now if I want to delete the name, I can just say del data frame, the column name, and in this case you can see that name is deleted. Now regenerate the data frame. The other way of deleting the column or a row is calling a drop function. This is preferable way of doing it, but it's up to you. So to use a column, you need to pass a second parameter in the drop function and it determines whether you are deleting a row or a column. 1 means you are deleting a column, 0 means you are deleting a row. So if I say df.drop age, which means that age will be a column which I will be deleting, and you can see that age is deleted. Now if I say drop 3 0, which means that record number 3 has to be deleted. So you can say that row containing value 3 is deleted. We can also delete multiple columns and row in one go by providing a list into a drop function. For example, in column, if I want to delete both name and age, this is the way I will do it. Now if I want to drop rows which is having values 2, 3 and 4, this is the way I will do it. You can see that 2, 3 and 4 are deleted over here. Till now we are deleting the column by passing the column name. If passing column name is tedious or there are chances of doing some spelling mistake, you can actually use the index to delete the column, and this is how you will do it. Let me regenerate our data frame. And if I want to drop it, I will call df.drop function with dataframe.columns and passing the column indexes 0 and 1, the age and designation for column, and this is how my resultant data frame will look like. Now you remember in the beginning I have said that Pandas data frame can be created from Python data structure like dictionaries and list. We have seen with dictionary. Let's see how we can generate Pandas data frame from a list. So the list has to be a two-dimensional array. Remember, a Panda data frame is a 2D array. So if you have a list which is two-dimensional, you can generate a data frame out of it, and this is how it will look like. Now Pandas data frame not only generate row index number but also column numbers as a sequence of integers starting from 0 if you don't provide any, and of course you cannot do that with list. But again, 0, 1, 2, 3 as a column name doesn't make any sense, but you can provide your customized column by this. You can pass an index as well as column. In this particular case, you can see that both index, row index as well as columns are being provided. If we can pass a list, then don't forget that Numpy arrays are equally welcome as an input in Pandas data frame, and you can see that I can generate a data frame like this from a Numpy array. Now one of the biggest USP of Pandas data frame is that it's extremely easy to do mathematical operations on Pandas data frame. So if I just do multiplication of two data frame, you can see that 2 into 2 is 4, 6 into 6 is 36, 13 into 13 is 169 and so on. Not only multiplication of two data frame, I can actually create a new data frame by multiplying it with a scalar value. You can see here that new data frame is data frame multiplication by 10, which is 1 becomes 10 and 5 becomes 50 and so on and so forth. We can also do some addition, or we can also do some bitwise operations. So that's all about basics of Pandas data frame. Before closing this video, I want to tell you what is a series. A series is nothing but a single column of a data frame. More than one series combines to form a data frame. Okay, that is what series is, and we will look more into series in the next video. So thanks a lot guys, thanks for watching. I hope I was able to explain things in the easiest possible way. If you have any queries or comment, please write it in the comment section. I'm looking forward for those. Thank you, thanks a lot, good day.